Hey everyone, and welcome back for another deep dive. Today we'll be taking a look at the work of Kip Thorne.
Oh yeah, one of the greats.
As always, we'll be guided by an essay.
Definitely.
This time it's by Yorgo Schneppet
Great essay.
about this visionary physicist whose work on things like black holes
Oh yeah, black holes.
and gravitational waves just really kind of rewrote our understanding of how the universe works.
It really did.
But there's a twist. Thorne's influence goes way beyond astrophysics
Oh yeah, for sure.
and right into the heart of quantum technology.
Which is surprising when you think about it.
Yeah, so I guess the question is, how did somebody who was so interested in gravity
Yeah.
end up influencing quantum tech?
Well, it all starts with his upbringing surrounded by academics.
Oh, so like a family business.
Kind of. Both of his parents were professors, so it's really no surprise
Yeah.
that he was so interested in science, even at a young age.
Yeah, you can kind of see how that would happen.
But it's his time at Caltech that really sets him on this path.
Caltech. Now we're talking.
A breeding ground for like all kinds of innovation in science.
Yeah, it really is.
And while he's there,
Mm-hmm.
he meets these incredible mentors like John Archibald Wheeler,
No.
who was working on black holes and relativity, and of course,
Yeah.
Richard Feynman, a pioneer in quantum mechanics.
Wow, that's quite a pair of mentors to have.
Right. It really highlights the importance of like a strong foundation.
Totally, yeah. And having these great mentors.
It makes a huge difference.
Yeah, so Thorne gets exposed to all of this, and it really shapes his thinking.
Exactly. And early on, he saw that there was a need
Okay.
to connect these classical physics theories, like Einstein's theories, with the world of quantum mechanics.
Wow, so he was a unifier
Yeah.
and saw all these connections when other people just saw separate fields.
Yeah,
Seems like a theme.
it definitely is.
So tell me a little about some of the breakthroughs he made in astrophysics.
Well, he made some huge contributions to
Yeah.
how we understand like space-time geometry in strong gravitational fields.
Which is
Basically how gravity warps the fabric of space and time around massive objects
Like-
like black holes.
black holes.
Exactly. And his work wasn't just theoretical.
Right.
It actually led to some predictions about black holes that were later confirmed.
Wow, like they actually observed them.
Yeah. And he did a ton of work on wormholes.
Wormholes.
Ugh,
Are we talking about like sending messages across the galaxy in an instant?
Yeah. It's definitely mind-bending.
Yeah.
But he thought that maybe wormholes could be stabilized
Mm-hmm.
and used as these channels for communication.
Wow, so is that even remotely possible?
Well, it's a great question.
Yeah.
But let's talk about LIGO,
Okay, go.
the Laser Interferometer Gravitational Wave Observatory.
That was a huge project
It was.
to actually detect these tiny ripples in space-time caused by massive events.
It was. And Kip Thorne was a founding father of the project.
Wow, they were trying to measure changes like smaller than an atom across kilometers?
Yeah, they had to use all kinds of cutting-edge techniques. Well, they had to use something called squeezed light.
Squeezed light. I have no idea what that is.
So it's a way to kind of manipulate the quantum properties of light to basically reduce the uncertainty in measurements.
So they were really pushing the limits of technology,
They absolutely were.
and it paid off.
Big time. They actually detected those gravitational waves in 2015,
Wow.
a monumental achievement. And in 2017, Thorne and his colleagues got the Nobel Prize.
A Nobel Prize. Well deserved.
Absolutely.
But I'm hearing that all the technology they had to develop for LIGO is now being used to make these super sensitive quantum sensors.
It really is amazing how these scientific breakthroughs can have such a ripple effect.
Yeah, impacting fields that seem totally unrelated at first.
You got it.
So we've got these amazing quantum sensors coming out of LIGO, but
Yeah.
I want to go back to black holes for a minute.
Okay. Yeah.
I mean, they really are the ultimate cosmic mystery.
We're sure.
And it seems like Thorne really spent a lot of time thinking about them.
He did. He wanted to really understand them.
So what was he focusing on?
Well, one of the key things was really trying to develop a detailed mathematical description of black holes.
Okay, now, you know I'm no mathematician,
Right.
but why is all the math so important when it comes to black holes?
Well, it's like a blueprint, you know?
Okay.
It gives us a way to understand how they work.
So by understanding the math,
Exactly.
you can like predict how black holes behave.
Yeah, and how they interact with everything around them.
So we can learn about things we could never directly observe.
Right. And it was crucial for LIGO
Oh yeah, that's right.
because they were trying to detect those gravitational waves.
So Thorne's calculations were like the roadmap.
They were.
So
Yeah.
LIGO to find those ripples.
Gave them the framework to make it all possible.
But he didn't stop at the math, did he?
No, he didn't.
What else was he thinking about?
Well, you know, the information paradox.
Oh yeah, the one where information is lost forever.
Yeah. And it really bothered physicists. It
Right.
violates, like, the laws of quantum mechanics.
So can you remind me what the paradox is exactly?
Sure. So, when you burn a book
Yeah.
in classical physics, the information, it's gone.
Right.
But quantum mechanics says that information is never truly destroyed.
So what happens when information falls into a black hole?
Right. Where nothing can escape.
It's a cosmic battle
It really is.
between classical physics and quantum mechanics.
With information hanging in the balance.
So did Thorne have any ideas about how to resolve this paradox?
He did. He actually worked with Stephen Hawking.
Wow.
You know the guy who first proposed the paradox
Yeah.
to try and figure it out?
And did they agree on a solution?
Well, they both believed that information wasn't lost,
Okay.
but they had different ideas about how it might be preserved.
So even the greatest minds in physics can
Yeah,
disagree.
absolutely. But those debates are super important.
Okay.
They help us refine our understanding.
So what were some of Thorne's ideas about how information might survive?
Well, he thought that maybe the information was encoded on the surface of the black hole.
Okay, so it's not lost, it's just painted on the surface.
Right. He also looked at how quantum effects might preserve information.
Quantum mechanics to the rescue again.
Right. It really shows how connected these ideas are.
So Thorne really was connecting these different worlds of physics.
He really was, and it led him to think about some crazy ideas.
Like what?
Well, wormholes.
Yeah.
Yeah, those tunnels through space-time.
I thought those were pure science fiction.
Well, he explored them mathematically.
So did he believe they could exist?
He showed that they are theoretically possible. They would
Uh-huh.
need some very special conditions.
So like what?
They would need matter with negative energy density.
Negative energy density.
Yeah, we've never actually observed that
So still in the realm of science fiction,
for now.
but it's still amazing
Oh, yeah.
that he thought it was even possible.
It really shows how he was constantly pushing the boundaries.
He was a real visionary.
He was. And that spirit is still inspiring physicists today.
I feel like I need to take a break and process everything.
Yeah, it's a lot to take in.
Black holes, wormholes, quantum mechanics.
Quite a journey.
It is. But one thing that really stands out to me is that Thorne wasn't just this brilliant theorist.
Really?
Actually wanted to see his ideas have a real impact.
He did. He was very focused on the applications.
And LIGO is like the ultimate example of that.
It really is.
Who would have thought we could actually detect these tiny ripples in space-time?
It's amazing.
And it shows how Thorne's work has really had this direct impact on quantum tech.
A great example.
Yeah, so we talked about how all that technology they developed for LIGO, like, the high-precision interferometry and the squeezed light,
Yeah.
is now being used to make all these incredible quantum sensors.
Right.
But can you give me some examples of how these sensors work and what we can actually use them for?
Sure. So imagine a sensor that's so precise, it could measure tiny changes in Earth's gravitational field, which could be used to, predict earthquakes or monitor volcanoes.
Wow, so we could have these early warning systems.
Yeah, exactly.
That would be incredible.
They can also measure magnetic fields incredibly precisely.
So what could we do with that?
Well, it could revolutionize medical imaging,
So
being
that-
able to detect these subtle changes in brain activity
Wow.
could lead to earlier diagnoses for all sorts of things.
So Thorne's work on gravitational waves
Yeah.
could actually lead to breakthroughs in healthcare.
It just shows you how connected science is.
It really does. But I remember we were talking about how Thorne had these even more futuristic ideas
Right.
about using space-time for communication.
Yeah, he thought about maybe using wormholes as these channels for transmitting information.
So are we talking faster than light communication?
Potentially, but there's a lot of challenges.
I bet.
Trying to create and stabilize wormholes is way beyond what we can do right now.
So maybe not something we'll be seeing anytime soon.
Probably.
But the fact that he even considered these possibilities,
It shows his imagination.
yeah, he really pushed the boundaries.
He did, and that's something we should all remember.
Yeah, there's still so much we don't know.
Exactly, and that's what makes science so exciting.
Well, it's been an incredible journey learning about Kip Thorne
It has.
and all his contributions based on that great essay by Yorgo Schneeppert.
Yeah, he really captured Thorne's brilliance.
So I hope everyone listening is feeling that sense of wonder and wants to keep learning
Me too.
about the universe and the power of human curiosity.
It's what drives us forward.
So until next time, keep those minds curious and keep exploring.